Hello guys, today we're going to be doing the multiplicity of roots. So let's go ahead and define multiplicity. What is the multiplicity of a root? The number of times a root appears in a function. Usually we can see the multiplicity when the function is factored. So easiest to see when the function is factored. All right, you can only tell the multiplicity when the function is factored most of the time. So let's go ahead and do this example down here where it says find the roots, find the degree, and the multiplicity of each of the roots for the polynomial functions. So notice I went ahead and factored it. So here, let's talk real quick. What are my zeros or my roots going to be? Well, I'm going to have to do x minus 9 equals 0. And I'm going to have to do 2x plus 7 equals 0 to find my roots. So let's go ahead and solve. So here, I'm going to add 9. My 9's cancel out. So I'm left with x equals positive 9. So there is one of my roots. Now let's go ahead and do the other one. So we're going to do minus 7. If I do it on one side, I'm going to do it on the other. My 7's cancel out. I'm left with 2x equals negative 7 divide by 2. Divide by 2. So my root on this one is x equals negative 7 over 2. All right, so we have our roots. X equals 9, x equals negative 7. Now let's determine the degree. This x minus 9 occurs 2 times because of the square. We have 2 of them. So this x minus 9 is a 0 with a multiplicity, and I'm going to abbreviate it, with a multiplicity of 2 because it occurs twice. This negative 7 divided by 2 occurs only one time because there's only one of these. There's a technical one right there. So this one has a multiplicity of 1. And that's how we would write it, like that. So let's go ahead and try another example. Oh, real quick. If we multiply this out, we have 2 here and 1 here. So our degree is 3. The degree of this function is 3. All right, let's go ahead and try another one. We have g of x equals 3x plus 1 to the 3rd power times x minus 3. How many times are we going to have this factor right here? We're going to have it 3 times. So let's look at this 3 on the outside. Will 3 ever equal 0? Will 3 ever equal 0? No. So we don't have to worry about that one giving us a 0. Now we got to look at x plus 1. What makes x plus 1? Well, x plus 1 equals 0 if x is negative 1. I skipped these steps. So we have x equals negative 1. And how many times does it occur? It's on there 3 times because of the exponent. So this has a multiplicity of 3 because it occurs 3 times. Now the last factor is x minus 3 equals 0. So again, how do I solve? I move that 0 over, x equals 3. And this one only occurs 1 time. So this has a multiplicity of 1. Now, what would be the degree of this function? Well, here I'm going to have x times x times x. So it's going to be x to the 3rd. And then I'm going to have an x right here. So that's going to be x to the 4th. So my degree is a total of x. My degree is 4. And again, because I have the negative 1 3 times, and I have the 3 1 time, so in total I have 4 roots. 4 roots implies a degree of 4. That is what the fundamental theorem of algebra tells us. So we have the negative 1 3 times, the 3 1 times, so technically we have 4 roots, even though 3 of those are the same, so the degree is 4. Go ahead and try the next 2. Pause the video and try the next 2. Alright, so hopefully you paused the video and attempted to solve these. So let's go ahead and do f of x. I'm going to start skipping some steps just real quick. So here, what makes x minus 1 0? Well, if x equals positive 1. What makes x plus 9 0? Well, if x equals negative 9. Again, I'm skipping that step of solving. And then this last one, I'm going to solve it just because it's multi-step here. Negative 2x minus 1 equals 0. Add the 1, add the 1. Negative 2x equals positive 1. Divide by 2. Negative 2. So x equals negative 1/2. All right, so what are my 3 zeros? My 3 zeros are 1, negative 9, and negative 1/2. And now we're going to talk about the multiplicity. How many times did I have x minus 1? I had it 4 times, so that's going to be with a multiplicity of 4. The negative 9, I have 3 times, because I got 3 of those. The exponent tells me that. So that's a multiplicity of 3. And then my last one down here, the negative 2 minus 1/2, it only occurs 1 time, so that one has a multiplicity of 1, like that. All right, let's do the next one. Ooh, h of x is a little trickier, and I meant to do that on purpose to kind of get your brains thinking. What makes x equal 0? Well, if x is 0, so what's our 0 in this one? X is 0 with a multiplicity of 2, because there's a 2 on the exponent. So that one was not as tricky as it looked. Just remember that if it's x, what gives you 0? Well, if x is 0, and it has a multiplicity of 2. Then the x plus 5, what makes that 0? Well, I subtract the 5, x equals negative 5, and this one has a multiplicity of 1, like that, because it only occurs 1 time right there. All right, so when we talk about multiplicity on a graph, it's a little bit more difficult to determine its multiplicity. We can only have a general idea of it. So let's go ahead and talk about what I mean. So if the multiplicity is even, the multiplicity is even, it's going to barely touch the graph. Barely touch, not the graph, the x-axis. Touch the x-axis. And this is as close as we can get with multiplicities on the graph. If the multiplicity is even, so if the multiplicity is odd, sorry, not even, odd, the function passes through the x-axis, all right? So for that to make a little bit more sense, let's look at these examples down here. Let's look at the first graph. This graph passes through negative 3 because the line goes right through it. It goes through the x-axis, through x-axis. So we know that x equals negative 3 is a 0 with an odd multiplicity. Meaning that it could occur 2 times, it could occur, it could occur 3 times, it could occur 1 time, 5 times, we just don't know. That's as good as we can get with the graph. So again, it's just kind of an idea out there, doesn't tell us much. Here, it's also going through the x-axis 1 time, so x equals negative 1. And it's also going to have an odd multiplicity. So it could have a multiplicity of 1, a multiplicity of 3, we just don't know. So that's as much as I'm going to require you guys to know. And then let's look at 4. 4 also passes exactly 1 time, so that's an odd multiplicity as well. So x equals 4, and then odd multiplicity. All right. Now, let's look at the second example right here. We have a negative 2. Notice that this is barely touching touching the x-axis because it doesn't go through it like these did. It barely touches it. So that -2, x equals -2, would have an even multiplicity. Okay, so that -2 would have an even multiplicity because it barely touches. But yet, right here, when we get to the 1, where x equals 1, that would be an odd multiplicity, and that's all we know. And then when we go to the 3, that's x equals 3 is a 0, and it passes through it, so that's an odd multiplicity as well. All right, go ahead and try the next example. Go ahead and try the next example on your own. So we're gonna try it, pause the video. All right, so hopefully you paused the video and you tried this example. So right here, x equals -2. And notice that it's barely touching it because it comes up to the -2 and then goes down, but it doesn't go through. So that is an even multiplicity. Now let's look at the next one. The next 0 is x equals -1. And it goes right through it, so that's an odd multiplicity. And then the last one, it goes through right here, is x equals +1, and it goes right through it, so that is an odd multiplicity. All right, guys, so that is it for today. We're going to be doing all these multiplicities. That's all we're going to do with multiplicities for today, and hopefully it wasn't too confusing. Let me know if you guys have any questions. Have a good day.